Compared to the one sample t-test, both the two sample t-test and paired t-test see far more utilization within the field and outside of the classroom. In this video, we'll be discussing the fundamentals of each with examples in RCommander. So prior to this video, we only utilized one t-test variant, the one sample t-test. In this lesson, we'll learn and utilize two other available variations of this methodology. So let's go over each. The one sample t-test is utilized to compare a sample mean to a specific value. It is used when the dependent variable is measured at the interval or ratio level. The two sample t-test is utilized for testing randomly sampled items from two separate control groups. Remember that, two separate control groups. The paired t-test, this test is utilized for sampling the same set twice, once for each variable. Now, the type of variation employed in each scenario will become increasingly evident throughout the following examples that we'll be going through in these slides. However, all test variants utilize the t-distribution as a foundational element for their construction. Like the one sample t-test, both the two sample t-test and the paired t-test can either be right-tailed, left-tailed, or two-tailed. Okay, so let me just drill this on home. One sample t-test can be right-tailed, left-tailed, or two-tailed. Two sample t-test can be right-tailed, left-tailed, or two-tailed. And the paired t-test can also be right-tailed, left-tailed, or two-tailed. And the methodology of application will depend on what the underlying scenario requires. So here is an example of the two sample t-test. In this case, we have two samples, okay? So a scientist creates a chemical which he believes changes the temperature of water. He applies this chemical to water and takes the following measurements. All right, so each one of these is a certain beaker of water, okay? So this is beaker 1 with the chemical applied, 2 with the chemical applied, 3 with the chemical applied. So in each case, this is an independent beaker of water with the chemical applied and the temperature measured. All right, he then dumps all of these beakers of water out and then goes to a fresh set, okay? So this is a fresh set of beakers of water. So he goes into his lab and just fills these up with water, different beakers, okay, fresh set, and he just takes the temperature. No chemical applied in this case, all right? These is just regular water in a beaker, 74, 75, 70. In each instance, it's a different beaker with water in it. All right, so this was a beaker with water and the chemical applied. This is a beaker with water and the chemical not applied. So can the scientist conclude with 95% confidence interval, that means alpha value of 0.05, that his chemical is in some way altering the temperature of water? Well, we see that it says the chemical in some way is altering the temperature of water. We don't want to know if the temperature is increasing or decreasing. We just are curious as to whether or not there's an effect. So that means it's going to be a two-tailed test. So here's our hypothesis. The chemical is not altering the temperature of water, is the null hypothesis, and the alternative hypothesis is the chemical is altering the temperature of water. Data's got to be structured a little bit odd for RCommander to perform the application of the methodology. But in any event, we're applying a two-sample, two-tailed t-test. All right? So this is how it's going to be achieved. We have RCommander ready to go. We already have the data imported into RCommander. And if you needed this data set or the subsequent data set, both of those data sets are in CSV format in the video description below. So go ahead and get those CSV files imported if you wanted to follow along at home. So go to Statistics in RCommander, Means, Independent Samples t-test. We have to pick the groups. Well, it's water type, right? Because there's two. There is the water with the chemical applied, and then there's just the regular water. In each instance, the temperature was taken. And our response variable is the temperature of each. So it's being grouped into two separate groups. One is the water with the chemicals. The other is the one without the group without the chemicals. And then in each instance, it's the temperature of each observation within each group. All right, select each and then click OK. We then have to go to the options menu. So don't click OK, actually select each, then go to the options menu or the options tab and select this button here. This button indicates a two-sided test. This here would be a left-tailed test. This here would be a right-tailed test. Our confidence interval is 0.95 because our alpha value is 0.05. We're going to assume equal variances. You're only going to select no if you're performing a two-sample t-test and one observation category is larger than the other. All right, so if we had, say, 17 observations for the chemical application and 10 observations for water without the chemical application, we would then select no here, and it would perform a Welch's two-sample t-test. And a Welch's two-sample t-test, the reason you would utilize that again is because the sizes of the categories are different, but the output would be similar. So you would have a similar output as to what we're going to see in the next slide, but you would just have to report that you've performed a Welch's two-sample t-test as opposed to just a t-test. But in this instance, our sample sizes are the same, so we're going to select yes. So here is our output. We have the t-value, the degrees of freedom, the p-value, the mean of water A, and the mean of water B. So this is how we're going to report our findings in the APA format. There was a significant difference in the temperature of water prior to the application of the chemical. Here is the mean of the one and the standard deviation as compared to the temperature of the water subsequent to the application of the chemical. There is the mean, there's the standard deviation. Here is the degrees of freedom. Here is our t-value, two significant figures rounded, and our p-value. All right. Now the question is, there's no standard deviation reported for either category here. By reported, I mean there's no output for standard deviation. So how would we report it if we don't have it in the output? Well, I'll show you how to do that now. So everything in yellow you can get from this initial output from performing the prior steps. But to get the standard deviation, you have to perform the following subsequent steps. You have to go to Summaries, Table of Statistics. This will bring the following menu up. We're still operating with water type and water temp. Select standard deviation as your option, and then click OK. This is the standard deviation for water A and water B. So with that, you can then complete your APA format. So that's what, 2.17 rounded and 1.67 rounded. So you'll just go ahead and place those there and there. Okay, the paired t-test. A watch manufacturer believes that by changing to a new battery supplier, that the watches that are shipped, which included an initial battery, will maintain longer lifespan. To test this theory, 12 watches are tested for duration of lifespan with the original battery. The same 12 watches are then retested for the duration with the new battery. Can the watch manufacturer conclude that the new battery increases the duration of lifespan for the manufactured watches? We will assume an alpha value of 0.05. So this is paired. And why is it paired? Because we have the same watch in each instance. So this is watch A. This is original battery, new battery. Watch B, original battery, new battery. Watch C, original battery, new battery. So in each instance, It's a paired experiment. All we're changing is the condition. So it's the same batch of watches, old battery, new battery. So paired t-tests will always have the same number of observations in each category. That differs from the two sample t-tests, which could either have the same number of observations in each category, or one category may be larger than the other. Now, we see that we're looking for an increase in the duration of lifespan, increase in duration. So that will indicate that it's a one-tailed t-test, and it'll be a one-tailed t-test to the right because we're interested in a significant increase. So if we're in a classroom and we're required to write out our hypothesis symbolically, this is what that would resemble. The new battery does not increase the duration of the lifespan for the manufactured watches. That's our null hypothesis. It's the status quo assumption. We're going to assume out of the box that nothing is going to change. The alternative hypothesis is that the new battery does increase the duration of lifespan for the manufactured watches. And here are each category and the paired measurements. All right. So here are our measurements, and let us proceed. So with the data appropriately imported into RCommander, we're going to go to statistics, means, paired t-test. All right. Now this is a little funky. All right. It's a little funky here. We have to do the application and then the original. So whatever it is, as far as the change in conditions, it has to be whatever the application is, which we're looking to utilize to disprove the null hypothesis, that has to be selected first. And then the second variable is going to be the original conditions. So in the case of the batteries, the conditions which we're testing for is we're testing to see if the new batteries have a significantly different lifespan than the old. So that is our first variable, and the original batteries are our second variable. We then have to go to options. We're going to select the third option for alternative hypothesis, which indicates a right-tailed test, so greater than right-tailed, okay? And our confidence interval is going to be 0.95 because our alpha value is 0.05. So here is our output from performing the prior steps. As you can see, we have our t value, our degrees of freedom, and our p value. Now our p is lower than our alpha value, so we're going to reject the null hypothesis, and we'll state that there was a significant increase in the lifespan duration of watches which contain the new battery, mean standard deviation for the new battery, as compared to the lifespan of watches which contained the initial battery, mean and standard deviation for the initial battery. T, degrees of freedom, t value, two significant figures, and p value, two significant figures. Now, as you can see, we did not, again, get the mean value output or the standard deviation for either category. So we have to perform an additional step to receive these values in the output to place them in the APA format. So get this first, and then go ahead and perform these following steps. You're going to go to Statistics, Summaries, Numerical Summaries, hold down Shift, and select both New Watch and Original Watch. So you have to hold down Shift as you click both of them, and then click OK. And this is the output which you should receive in your R console. Now I've made these colors to match the APA format. Obviously, this will come out in grayscale. But as you can see here, here is the mean for the new watch category, watches with the new batteries. Here is the mean for the original batteries. Here's the standard deviation for the new watch batteries, and here's the standard deviation for the original watch batteries. So with all of that, you can then complete the results of your experiment in APA format. So you should be all set then. So with that, we will end this particular lecture. I hope you're able to take something away, whether it be for your class or for any research that you might be doing on your own. I wish you all the best of luck in either regard, and I hope you have a wonderful rest of the day. Please consider liking and subscribing, and take care.